All right, we're back for part 3 of Senior Developer Tries to Code Quicksort. I wish I'd memorized this a long time ago. This video would have went so quick. This is your lesson here. Don't learn from my mistake. Go learn Quicksort. All right, so we left off in a broken state, or I left off. You had nothing to do with this monstrosity. So, oh my gosh. Okay, so I've got my partition. So the partition should be the piece of code. By the way, this is unedited, unscripted. I've not researched any of this. I mean, it should be obvious, but that's all my videos. None of it's scripted or edited. It's just on the fly, whatever. I try to show everything. Um, so partition should be the part of the code that throws all the numbers on either side of the pivot. So that's what this does. TMP equals num0. That's the first one. Partition position, left, right. So this code works. It throws everything to the partition or on whatever side of the partition it's supposed to be on. So I know that. Now I'm thinking the sort is the one that should be doing all the recursion and all that. So what this actually does is this is placing the pivot. Place pivot in position. So this is actually misnamed. This should be place pivot. That's what that should be. Place pivot in position. And that really should be initialized. We shouldn't have uninitialized variables. So we're just going to do like a -1. It should never get to that, but at least we'll know if it does exactly what that issue is. Whoa, need to brighten that. Now the sort, this should actually be partition here. This is where we throw everything around. Because that's really how it's actually sorting. Instead of going through every, value of n through the whole thing in step like an ON algorithm would, we're actually partitioning this, taking sections of it, divide and conquer, throwing things on left and right of a pivot until we get down to 2. So this takes a pivot and then throws numbers left or right of the pivot, and then it calls the partition, which this should be called, or this should be place pivot in position there. So this should be, let's see this, copy that. So that should be right here. And partition should be the name of this. And now I think what I'm going to do. So on this, the only thing we should do here is just pass in the array and the length of the array. So let's pass in nums here and the num count. And then we'll move this. Into here. And then quicksort is kind of like a wrapper function that ends up managing the whole thing. The recursion and blah blah. Okay. So let's see. So nums count. So quicksort will do that. Or maybe not. So this will be, we'll have the length, but we'll have, let's see, integer nums there, and then length. Length there. Now we don't have this anymore because I think I'm moving all this into somewhere else. Probably into, we have partition. No, this should be it. So let's see. One of them has to be recursive. So I guess it should be this. So we should probably take a pointer to that. Well, I mean, that really doesn't matter. I mean, we're talking about 10 numbers anyway. So but maybe it should be the partition. So if we do nums there, here. So if we take this out, don't need that. So if we get the partition position and then we recall that, So if we did this, sort left, right. So the sort, it would go in and do that. Return. So that means this has to, everything in here would have to take this. The nums. We need a length. It doesn't look like it, so there. Um, here. It's there. Sort left. So then left side, right side. So, okay, let's see if we can get to a, oh, I already got one open. So if I can get to a compile stage. What is it? Quicksort or CPP. 67 right here, left, right. So Quicksort. So I guess we would have to take it in from there. So integer. Then you can take those in, and then here, sort nums count. So left, right, nums length. Let's make that consistent for. Oh, wait, let me 0. My allergies are so bad. It's horrible. It's like something's just constantly in my throat. Oh, so we go here, and this is where all the recursion happens. So, left, right, nums length. We need this so we can know, you know, the length and where the indexes are to recall it. This actually will run sort for the work. But the problem here is I'm going to have to get the nums back too, so may have to just put that back as a global. Or we could borrow something from OO programming. Just return an object with crap in it. So let's do that. Let's do Struct, no. Should we name it result? Struct result. Let's see, S. So, and this will be, what would it be? We need the nums in it. So we need integer nums. There. And what else? Partition position. There. So do that. And then we can return that instead. So everything will return a result, an S result, or a result. So, and then quicksort here. We're still going to need it back here, so. But we only need, at this point, the nums. So, I wonder if we can reassign that. Equal quicksort there. There. In position, so this would be might not need that now. So, oh, we don't need that. We can use S result. We can use that one global for all of it. Yay. So instead of that, let's see, S result. Well, we don't need that now because it's just going to be in there. As long as we access it after we fill it. So we don't need that. We don't need to return them. These will all be void. There. Oh. So the whole idea of this left plus plus was because the pivot's on the very first element. So we always start from the left. But I'm not sure if that messes things up or not. At some point, if it's just two numbers side by side, we don't need to do it. We just need to see if they need to be swapped. So quicksort here, here. So this would be this result dot partition position. There. I don't need this anymore. And here we can do Let's see. Should be the ABS, just in case left is greater. Well, left should never be greater, though. Right minus left. Less than 2. Turn. And then we got let's see if left is greater than nums right. And then that should be the end of that one. That should just be return. And then otherwise we're going to sort because it's at least 3. So there'd be at least one pivot in there. Okay, then we call the left, or quicksort on the left side. Which should be because by the time it gets here, left is going to be either equal to right or greater than right by 1. So if left equals right, it's going to be right at that point. Otherwise, it's going to be below. So either way, it would be right. It's right on each one of these. So we might as well make that right too. There, and we don't return anything now. It's not really OO, I just meant that we were going to use an object. This should be named pivot. Oh, well, I guess we don't even use it. Why do we even have it? Where's temp coming from? It's because I moved everything around. Oh, temp was the old value. Duh. Okay. All right, let's see what we got here. Pivot in position. We don't need to return this anymore. There. Shouldn't be any returns in these. Quicksort return that is that bells out. All right, see if I can compile it. Start result has an illegal zero size array. Thank you. Yeah, it does, doesn't it? Oops. It does not know how many to do on that one. Sort identifier not found. 81. Where's that at? Sort left, right. What was that called? What we call partition now? Okay. Does not take two arguments. Oops. You're right. It don't. Left, right, nums. So if I do not take three arguments, 84. Left, right, nums, and nums length. Okay. Left, right, nums, and nums length. So that would be the length of that one. So it needs to be here. Oh wait, that's got to be S. But that's got to be from the structure. So each one of these, after it changes anything in that structure, has to return it. Or has to place it in here. So when we come down here, like there. This result dot result dot position equals -1. Okay, blah blah. So this one is going to be nums from here. But after this, it's not going to be quicksort anymore. We're just going to call quicksort here. And then this would be this one here. Equals S result there dot nums. And then we can do it again. One last thing here. So that So we're working on a copy of nums here. Left. Actually, we don't care to do that right now. Yeah, we do from here. But we don't have to change it here. We don't have to use sResult. We're just going to use nums and we're going to pass it into partition. Partition will actually change that. And honestly, we can actually get away from it. I mean, this is a big no-no, having a global and then having all these functions changing it. That's not good. It's not thread safe. All right, we don't even need it anymore. Let's just work directly on it. But, well, it's just because we needed that, though. Yeah. Copy that. Dot. I should not do that. I should do this here. Well, yeah. This is feeling really dirty. Take this out. Gotta have one source of truth. Whether it's past in or global, it's gotta be one or the other. There. Don't need that anymore. Oh, it's cold. I gotta start the truck, turn the heater on. There. Don't need that anymore. Don't have it there. So the partition position 2. Actually, don't need this either. Just use it directly. There. Okay, now is there anything using the partition position in here? Result there. Partition, left, right. 0. Alright, see if we can compile. So far, does it take 3 hours? Where's that at? 84. I thought it did. Oh. I did fire 74. I knew I'd miss one of those. I knew it. Too many of them. Usually you don't want to do that. If you got a bunch of stuff like that. It's not assignable. Where's that at? 94. Okay, there's something known as equals. Oh, it's not assignable. What does that mean? Does that mean that? Okay, well, we don't care about that because we can just make this. We can just fill the structure. I think. Probably not, but. Or we just do it from up there, I guess. Yeah, we'll see if we can do it here. I have to do them individual. This 10. Don't need that. Just no sun. Okay, 92. We can't do it. Oh, I can't do that. Huh? So what would that be? Rand mod 10, maybe. Was it time? I think. Is that what has Rand? Let's see. Or the time. Let's see, blah, blah, blah. Yeah, we can do it there. Let's see. I don't even know what this is. Where's my... Let's go back to the road like. How do we do that? So we had time.ah. Where do we do srand at? Should be in like miscellaneous. Initialize miscellaneous. Here it is. Srand time null. Okay. Srand time null. So srand. That and then. Ooh. I'm cold. All right. I gotta start the heater. Okay, and where we're using rand? I want to make sure I got that right. The heck is that? Okay, yeah, mod 50, and then plus whatever your minimum's gonna be. So, okay, got that. And then rand and mod 10, so it can be 0 too, but that's fine. 0's fine. Okay, so we got that. We initialize these to random numbers. Actually, let's just do it 100. That. There. Okay, Quicksort doesn't take that many anymore. Doesn't take nubs. Okay. Okay, missing 96. Semicolon. Where are you, semicolon? Oh, forgot it. How do you forget that? Good grief. I am old. Okay. Oh, I was already there. Duh. There we go. Okay. Oh, wait, I already did it. I think my mind's on other things. Okay, where is... Oh, I never ran it yet. Okie doke. Oh, I did the wrong program. I forgot I got main in that program. Oh, man, what did I... Okay. Quick sort there. Now I do a... Is it shift tab? Yeah. All right. So we got those. 726, 25, hit space. I don't get nothing. Okay. So it's still broke. So where's a loop? Somewhere in here. All right, let's do this. See if we can get the first partition. going here. So it's the exact same thing. So it didn't, well, no, it's not. So the partition would have been 62. So it did do something. We never called partition though. It didn't set the partition though. All right, right here it should have partition and then place pivot in position. All right. So place pivot in position. Oh, wait, not in Visual Studio. Oh. Oh, I think I need a brownie. Where are my brownies at? I ain't got no coffee, so. It ain't time for y'all to eat yet. Actually, it is. I need to feed them. Alright. These little brownie bites from Walmart are pretty good. Alright, go here. Back to this. I do not want to do an update. No. Why am I even connected? I do not need to be connected. So Windows can do all its stuff in the background. Okay. Open up that. And then we can run this sucker. Woohoo. Run it, man. There we go. Set our breakpoint at our pivot position. Right there. And attach. Quicksort. Do it, man. Here we go there. Load all that stuff in, and let's do it. So left is 5, right is 5. So they ended up even. So that means down here, it should come in right into here. So let's do that. Goes into there. What's that? Let me watch this. Result. So here's our numbers here. Rotation positions, so it's never been used yet. So 29, 28, 18, 0. So it did partition. Because, or I mean, it threw everything over. I mean, it did partition, yeah. That's the sort thingy. So then we had different. Yeah, the only problem, oh, I can do it here. So the original was 29. So 29, that's the pivot. 28. So it should come between 27 and 58. That should be our pivot point right there. 0, 1, 2, 3, 4, 5. So right there, it should be right there. But that also means it should go down, it should exchange with that one. Let's see what happens here. Where are we at? So our pivot is 29. What is left? 5, 0, 1, 2, 3, 4, 5. Okay, it is less, or no, it's not greater than that. Right, it doesn't equal right. Oh, wait. Oh, it doesn't do anything. Oh, wait a minute. This should be in the placing the pivot in position. Yeah, so this is wrong. Pivot is 29. Minus 5, 2. If it's greater than it would do this. So this should be, if it's less than or equal. Because it's less than. But you still need to put it in position. Greater than result. Should it be less then? Huh. I mean, technically you could do it, but you're just going to have. I mean, yeah, we really don't have to place that because it would still end up sorting because it would be the pivot again, and then it should be thrown over, switched out with 27 at that point. And 0 and 28 would flip. Or no, no, I'm getting confused now. It does need to be swatted, but not with that. Pivot is copy that. So then num 0 equals pivot. Did we save the pivot already? Yeah. Okay. So this would be left minus 1 at that point. Okay, why do I have a finger thing there? Shouldn't it be an arrow? That's 1. Okay. here. So we got 11, 10, so our pivot's 11. So everything except the 10 is in place. 0, 1, 2, so left is 87. Come on. And right is 87. So they met right there. 87. So equals right, yes. So if pivot is 11 is greater than, oh, dang it, come on. Ugh. Left 2, 0, 1, 2, 87. So it is not greater than, so it should skip past that one. Go into our new code there. Go here. What? So then it goes back to that. Then it ends. Then we continue. Well, it shouldn't have two tens. We lost our 87. All right. Please tell me I didn't mess up the swap. Really? Okay, which one was it? This one? No. Right here. So num0 equals num's left minus 1. Because left is always on that high number. It's 1. Oh. Should be left minus 1 again. It's minus 1. Alright. Do that again. Do that. Let's not attach and let's just run this. Okay, 0 is definitely not a good one to do. Let's go ahead and set a minimum, because that is crazy. That's just dumb. Because if it's 0, I mean, technically it could happen, but everything's going to be to the right of it, and we're not running the right, so technically it worked. All right, let's do it again. So this time we do that. Our pivot's 34. Okay, yeah. 34. We're looking for stuff that's less than over here. So 0 greater than 34. This one. So 0 and 43 should have changed. Yeah, it did. This one, 61 needs swapped, but it never gets there. So they all should have met where? Because this would have stopped at 61. This would have swapped a 0 out there. Would have went to 8. 8 is lower. 48's here. So 61 and 48 should have been swapped. Oh no, because that's not lower. So where do they meet at? Oh, that's why. That's why it goes in the loop. They never meet when neither one of them have a number that has to go on the other side. That means one of these has to keep going. Let me see. Where's our partition? Here. If while left is less than right. Okay. Oh, that keeps it going right there, but and then they only swap if they do that. Well, actually they should keep moving anyways. See, if right num is greater than pivot, then it keeps moving. But if they both stall out, so if we keep them moving anyway, the problem is they won't. Num is greater than pivot and right num is less than pivot. Now we could do the other case here. um, the problem is if we keep them moving, then the pivot's not going to be in the right place. I don't know what they do. I don't know what the real quicksort does for that. So I'm stumped. How do you prevent that? So this is looking for stuff greater than. So it gets right here. So we start here. We go to here. So this is greater. We're looking for less than over here. So this gets to here. $27 is less than. 43 is greater than. So 43 and 0 swap. And then they move to 8 and 61. And that's where they get stuck because it's not greater than pivot and right's not less than pivot. So they're both there. So I guess they should both advance. So this moves here. That one, yeah, they should both advance at that point. That's it. See left knob, less than pivot. So at this point they're stuck. So we need to move them there. Otherwise, they independently move. Okay, so do that. Do that. It's still somewhere in a loop. Yeah. Okay. Okay, we got attached. Let's do the partition here. So right's 9, left is 0. So left num is 92. Pivot's 84, right num is 5. So those should swap. So that should go into that one. So 79 is 61. So left num is greater, right num is less. So those should swap too. Oh, no, it didn't. Pivot's 84. Right num is 61. That's less. It should be swapped. Oh, it's not greater than pivot. Okay, 79 is not. But that one's less than. Okay, so on this one, it should skip that one too. And it should skip that, and then let's see which one. Okay, so it right was stuck there, and then left moved. So let's go, let's wait until we get to this point. Let's go ahead and continue. Okay, so we got here. 8. So it never did anything again. Yeah, all the way to 6. Because everything after that was less than. So the left never had to swap. So they both met right here. So, one to there. And our pivot is 84. Left equals right. It does. So 8's going to be 61. Pivot is greater than that. So it should swap with that. Right there. There we go. And it did. So now 84, everything over here is greater, everything over here is less than. So we should be able to sort the left now. So we go back. Oh, we didn't run it anyway. We don't have it in there. So that part of it works. But when we go back here, how come it didn't print out? This result none, see, blah, blah. See, it should have printed it again. So I don't know why it didn't do that. Oh man, shoot. Step out. Oh shoot. Oh, I forgot I'm in an iterator. Okay, step out of that. I don't know what happened with that. Oh, there it is. So yeah, okay, that works. So that part of it works. Let's do it again. There. But how come it did? Oh. So pivot was 60. 60, everything's greater. These are all less. Okay, so we got the pivot's 5. Okay, so what happened there? So there are some instances where this is, I wonder if the 0 is making it screw up. Because none of these had 0. That one had 0. 84, and it worked. So it's almost like some of these don't work. All right. And I don't know why. Well, it definitely didn't sort. Well, that's a 91, so it definitely didn't sort it. Okay. Okay. So let's stop it at this point. Okay. That. So we're not even getting there. Hmm. Yeah, we're stuck in that loop. See how it popped up? Oh. Pivot is 60. Left is 22. So it doesn't go. Right is 9. So that should swap. So let's do that. Oh, wait. Okay, left is 1. Right is 9. Pivot is 60. So they're both less. Right is ready to swap, but left is not. So it skips over that. Left is less than pivot. They're both stuck. They're both not stuck. So we'll go here. Oh, wait a minute. They're not. Left number is 21. Oh, it's less than. Right is 92. Pivot is 60. Oh, okay. Pivot 60. Okay, yeah, so those. No, those shouldn't swap. The left is looking for greater than. Oh, man. Oh, they're stuck. That's right. So left's 21. Yeah, they're not going to move. So we move them, move them. Okay. Go back. Now left is 1, right is 9. Wait a minute, what was that? How could left be 1 though? Oh man, it's cold. I need to just leave this on. um Yeah, how could left be 1? Is this just that because this ain't the first iteration? So left number's 21, right number's 92. Ain't that the same thing we just did? Right number's 92 is greater than. So on here they're both less than pivot. That's greater than pivot. So yeah. So left number should advance, right number should decline. So, oh crap. I did left num, right num. Oh, shoot. It should be left and right. See? Oh, man. Really? Oh, my gosh. That's crazy. That's the copy paste. Good grief. Man, you gotta be kidding me. Do a control C on that. Quick sort on that. So pivot is 37. Okay, so that partitioned correctly. Let's do that one. 76. Okay, so those are good. That part of it's working. Now it's just this one here. So let's follow the left end. See where it goes. The petition's 87, so everything's lower than this. Okay, so we're on the left side. Oh, wait, we never hit anything. Maybe that is the, really? Or did we? Didn't even start it. Okay. Okay, place pivot in position. Okay, we don't care about that. We want to get down here to this right here. Right here. So let's go into that. This was 8. So 0 to 8. Partition position. Oh yeah, it is 8, isn't it? So it's at the very end. So left is 0. And it should be partition position -1. So 8 or 9 minus 1. This should read 8, actually. Oh, no, it's not. It's 9 minus 1. Okay. And this would be 9, which is the length. And that's not right. The length of it should be partition position or length minus partition position. No, it'd be 0 plus partition, or not 0, but left. No. So if we had 10, what would it be? So if we had it here, it would be here to there. Oh, the length. On this one, it should just be the partition position. So 9. Because remember, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not right, though. Why is the partition position 9? Because it would have hit left is greater than right, which would have been right here, not equal to. Pivot is greater than right, which it's not, so it never even did anything, right? Because it was 87. Our pivot point was 8, right? What is... No, the pivot was that, which was 87. So pivot 87 is greater than that. Yes, it is. So it goes in here. Num0 is 87. We exchange it with right, which is 60. Now right equals pivot 87. And then partition position equals right. Oh, that is right, isn't it? Because there's nothing on the right side of it, so it is in the last place. What am I tripping on? Wow. Okay. Cool. Let's go into Quicksort. Num's length is 9. Oh, that's what it was, the num's length. Oh. That's why it's all messed up. Okay, let's go here. 0 and 8. Num's length is 9. So that is not going to trigger. That is not going to trigger. I'll go to partition. Let me sort it again. Oh, wow. Okay, so we don't need the length on left side, apparently, because we're not even using it. We're not even using it in here in Quicksort. What's it even being? Okay, so let's go into position, or partition, 0 and 8. So everything on the left side of 87 should start sorting. So pivot will be 60. We got our pivot of 60. Now in increments left, our left is 1, is 8. So we go through that. Left num, right num. Left num is 37. Right num is 1. Pivot is 60. So right num, this should swap. Left num should not swap. So it should skip this one. Go to this one. And then left num is 37. That's less. And right num is greater. That's not. So it should. What are you guys doing? Sparky, you sure are loud. He's cleaning his paw and it's like he's smacking his lips or something. Okay, so we go left num is less than pivot, yes. Right num is greater, no. So it skips that. Goes here and they move independently. So left becomes 2, Right does not move. And then we go back, go through it again. 47. So this is going to go all the way because 8, 1. Oh, wait a minute. What is right? What's the right num? 1. Okay, so right num is less than 60. That needs to be swapped. 4, 5, 6, 7, 8. But why didn't it swap before? What was it on before? Because, well, it couldn't swap because of left. That's right. So left is on, it should be on 47 now, yeah. And it never swaps, so they should meet at 8. Which is the exact same thing. Oh, man. So it's got to go all the way through all this stuff again. Look at that, until it equals 8. Because nothing gets swapped. Yeah, this is like the worst case on Quicksort. Oh, wait, it actually did get swapped. I wasn't paying attention. It should not have gotten swapped. Oh, yeah, it did. I forgot. I didn't see that. 68 got swapped with 1. So now 60 and 22. Pivot is 60. Right is that. What's left num, right num? So 22 and 35. This is less than. This gets swapped. That doesn't. So I keep going. Now they're both on 7. Okay. So now it skips that. Goes to place pivot in position. And pivot still equals 60. So they're both on 7. 0, 1, 2, 3, 4, 5, 6, 7. They're both right here. 60 and 35. So they're both equal. It's greater than left. It's greater than 35. So it should get swapped. Yeah, 60 here, 35 here. So the new pivot is 35. Oh, how did we get 2 1s? Oh, that's going to be a problem. I wonder if that's it, because I just picked random numbers. Because I don't think I've ever put an equal sign in there. So left is 0. So this would be 7 minus, so it'd be 6. 1, 2, 3, 4, 5, 6. So now we're on 22. Partition that. So 37 gets swapped. 22 gets swapped. So we should do a swap there. And we do. Okay. So we go back. So then we go left, right. So right num is 1. That gets swapped. Left num is 47. That gets swapped. Okay, so now we got ones together here. So right is 16 and 1. 1 does not get swapped, 16 does get swapped. So now they're both equal to 4. Place pivot in position. Left is 0, right 35. Okay, there left and right are 4. Pivot is 0. Oh, we haven't initialized it. So we go there. Left equals right. Pivot is 35 greater than num's left. So it's not. Pivot is equal to num's left, which is 35. So it doesn't go there. Pivot's 35. Why is it going in there? Oh, what's left? Oh, 4. Oops. 0, 1, 2, 3, 4. Oh, it is greater. So it swaps with 16 to put it in place. That's correct. Okay. So we did that. 0, 4 minus 1, so now it goes to 3. 3 minus 0, no. So it goes to partition. So now the pivot is 16. 1, 3. Less than right, yes. Pivot 16, so left num gets swapped. Right num gets swapped. So 16 and 1 get swapped. And now they both equal each other. So now we're at that. Now we just need to partition that. But left and right are equal, so it's not going to do that. Now we go in here. So now the pivot, still 16. Left equals right. Greater than that. Yes, it is. So it goes in there. It swaps out with 1. So that is actually okay, so the problem is it went all the way through, but they're not sorted. And there's no chance for it. See, the 37's out of here. There's no way to run that again, to know how to run that again, so I don't know what is going on with that. Because the right side's not even gonna do it. And that's the problem. I think. But that doesn't explain it like in an infinite loop or something. Oh, wait. What is it doing? Why does it keep going there? Oh, okay. It's just coming back then. Okay, it's finally back. There, and then it goes on. Okay. And it continues. So that was the whole thing. It almost sorted it. It's just this number here. So if we go there again, 73. So there's a few numbers out there. I'm thinking I'm thinking there's an edge case there of when the pivot is on either side, it's not going to sort all the numbers on the other side. These are sorted. So 71, so there's going to be stuff on either side, so that one should sort. At least on the left. We're not actually even sorting the right. I think we're just, yeah, we're not sorting the right. Okay, so now we got some kind of bug again. So there's definitely a bug here, and I do not know what it is. And I think this has been too long again. Well, not really. This is real life. It's unedited, unscripted, unresearched. This is just me winging it. Can you imagine being on the interviewing me and then having one of those? Because I've been in a few interviews where they say, "Oh yeah, figure this problem out, and we'll just stay here until you do it." Can you imagine that? Here we are, like 4 or 5 hours into it. It's like, dude, you failed. Let's go home. Uh, nah, man, nah, we gotta. You, this is your problem. We gotta finish it. Keep them up till midnight. Okay, that's enough of this. All right, I'm gonna call this one, and I'll hit it again next time. My battery's running low, and the sun is setting on this pond. All right, guys, thanks for hanging out. If you like this stuff, hey, you like watching me code and, try to figure this stuff out, give me a thumbs up. Please subscribe. It really helps my channel. Um, I don't know. I'm not the goofball I might look like, but hey, this is fun to me, even if I'm having trouble figuring it out. But thanks for spending your time with me. I really appreciate it. Um, have a good night. Bye bye.